Welcome back to the London Futurists podcast. This episode is a bit different from the usual because today we're interviewing my boss. I say that mainly to tease him because he thinks the word boss is a dirty word. His name is Daniel Hulme and this is his second appearance on the podcast. He was one of our earliest guests long ago in episode 8. Back then, Daniel had just sold his AI consultancy Satalia to the advertising and media giant WPP. Today, he is Chief AI Officer at WPP, but he's joining us to talk about his new venture, Conscium. Also joining us is Ted Lappas, who is Head of Technology at Conscium, and he's also one of our illustrious former guests on the podcast. By way of full disclosure, I am CMO at Conscium for my sins, and David is on our advisory board. Daniel and Ted, welcome back to the London Futurist podcast.
Great to be here, Calum. David.
Thank you for having us back.
Looking forward to a great conversation.
Daniel, why don't you start us off by giving us a brief history of Satalia, where Ted also works, why and how you founded it, how you grew it to, I think, was it 200 people with no external capital, how you sold it to WPP, and what your role there is now.
I guess I've been involved in AI for now over 25 years. My undergraduate at UCL was AI before it was called AI. My undergraduate turned into a master's program. For my master's project, I was building artificial life agents that were evolving in a very simple environment and trying to understand whether you could have intelligent behaviors emerge. That then led on to doing a PhD. My PhD was originally modeling bumblebee brains, trying to understand their visual system. And I recognized 20 years ago the bottleneck in neural networks in this space was how quickly we could train large brains. And at the time, Jeff Hinton was parallelizing the training of these brains on GPUs. I went down a different route, looking at computational complexity and algorithmic techniques to try to understand how do we accelerate the training of brains, which led me into a different field in computer science, which is optimization. So my PhD sort of spanned two fields in computer science. The first is neural networks, and the second is computational complexity. And I recognized that there was a massive opportunity to bring these algorithms into industry. Industry very rarely get access to the bleeding edge algorithms that are being developed in academia. And I felt there was an opportunity to be a conduit from these technologies into industry to solve industrial problems more efficiently. So I started Satalia as a conduit, both a services company and also a technology company, to allow industry to engage with bleeding edge academic algorithms that I guess we might now call AI. For the first 5, 6, 7 years of the organization, I was primarily solving one-off problems for organizations and built up a reputation to understanding how do you apply algorithms to solving frictions across supply chains. Tesco was our first big opportunity where we were commissioned to build their last mile delivery solution, again, applying optimization algorithms and applying machine learning algorithms. And then the organization grew quite quickly to 150, 200 people over a period of 5 years, as you said, without external capital. Then it was acquired by WPP to both be WPP's deep minds. So how can we apply algorithms to hypercharge their supply chain, how we can take AI to pretty much every brand that they touch. And also I'm very honored to take on the Chief AI Officer role, where I'm thinking about the responsible and safe implementation, application of these technologies. So Satalia still exists within WPP as their deep mind. And over the past year, because AI has now happened, we've now doubled in size. So it's been an amazing growth story as well.
I think you've told me in the past that you don't think optimization, which was the main route to solutions offered by Satalia, you don't really think of that as artificial intelligence. Is that right?
There's obviously a popular definition of AI, which is getting computers to do things that humans can do. And you already know my opinion, which is I think that's a weak definition. I've built an entire career around helping organizations understand a better definition, which is goal-directed adaptive behavior. Systems that are able to make decisions, learn about whether those decisions are good or bad, adapt themselves so next time they make better decisions. The fact is, if you apply what we do in industry to that definition, you might argue that nobody's doing AI because most systems don't really adapt themselves in production right now. Now, that's a ridiculous statement to make because over the past few decades, new advances in algorithms plus data plus compute allow us to do some incredible things. So actually, over the past few years, we've developed a framework to think about AI as applications rather than definitions. I believe that there are broadly 6 categories of applications or frictions that exist across any supply chain in any industry that can be mapped to one of these 6 applications. One of those 6 applications is complex decision making, where optimization algorithms really lend their strengths to.
You very modestly avoided mentioning the scale of your achievement in selling Satalia to WPP, but it is a public figure. Do you want to tell us how much you sold it for?
It was rumored to be sold for $100 million, which we're very, very proud about. What that has done is it has enabled me, some of my team, to now think about how we can reinvest that money into the next generation of AI.
Which is a hell of an achievement and kind of crowns you as the Demesis Habis of WPP. Ted, we should hear a bit about your background as well, because some of our audience may not remember all the way back to your first appearance. Tell us about how you got involved in Satalia as well.
I'll do my best to give a quick intro. I've been in the space, the algorithms, let's say, space for almost 2 decades now. I'm from Greece, from Athens. I left Greece 2006 to go to the US to do my PhD. Back then, it was a differently defined concept. So it was a PhD on basically databases and data mining. I worked with different companies in the US, then I became an academic. I'm now back in Greece. I joined Satalia about 6 years ago to lead the data science team. It was a much smaller team back then. I think there was 11 of us or 12 when I first, and there's now 40 people in the team. Very wide capability spectrum in the team. My own area of expertise is mainly algorithms for text and graph structures. But the team has, of course, everything you can think of in terms of computer vision, algorithms for optimization, text mining, time series modeling.
So let's turn to talking about Conscium. Conscium is spelled Conscium. And if you don't look too closely at the cases and the declensions, it means conscious in Latin. What is Conscium trying to do?
I've been asking myself over the past year or so, what are the challenges that humanity is going to face over the coming years? I did a TEDx talk about 4 or 5 years ago where I suggested that there were these 6 singularities. And I know, Calum, you've already coined one of them. One of those singularities is the technological singularity, which is where we build a brain much smarter than us. I think that our community felt this wasn't going to happen for another 30 or 40 years. But because of the explosion of AI, the arms race that's now been created, it might now happen much more quickly. And I think that what we're going to see over the coming years are human beings either attributing consciousness to things that are not conscious, maybe even building relationships with them and things like that. We also run the risk potentially of building machines that are conscious and not realizing it, and putting them in situations where they might be psychologically tortured or turning them off. And if you've read Nick Bostrom's book, Superintelligence, he coined the term mind crime, which really means that we have a duty of care towards any consciousness, whether it be animals, humans, or even now AIs. So Conscium is trying to figure out how do we build, and if we should, safe, responsible, conscious machines.
Yeah. And the company's got 3 work streams. One is directly tackling this question of what consciousness is, what would consciousness in a machine be like, and critically, how could we determine whether a machine has consciousness? Second stream is neuromorphic computing and developing advanced agents. And the third stream is verification, creating environments to verify the behavior of agents aligns with human values. Let's take those streams in turn. Ted, you've got a very interesting relationship developing in that first stream. Do you want to tell us a bit about how we're proposing to tackle this rather vast and anciently unsolved problem of what consciousness is and how to detect it?
Sure. Let me first start by saying that I think we're now at the precipice of a super intelligent AI. It may happen in a year, it may happen in 2 years, it may already be here. And everyone is focusing mostly on intelligence, capability. And we're overlooking, I think, this aspect of consciousness, like Daniel mentioned, which to me is very, very scary to ignore that. The positive thing is that if you look in the literature on human consciousness, there is a vast, vast amount of work over decades and many, many brilliant minds working on this space. I wouldn't say there's a consensus yet, even in human consciousness, on how to measure it, detect it, define it. And then if you think about moving all this knowledge to AI, it's quite a task, a very interesting task, and one that I don't think we can do without tapping into that vast work that has taken place over the past many, many decades. One of the most, I think, brilliant minds in this space is Dr. Mark Solms from the University of Cape Town. He's been leading, I think, the effort in many, many, many different directions. There are many different ways in this consciousness approach. And he has moved, I think, successfully from the study of human consciousness into AI. And that's my personal opinion. If you are looking for a person to help you make that transition, I think he and his team are the best place to start. So we've made a big effort over the past few months. We found a lot of common ground, and we're now beginning a collaboration for him and his team to work with us and help us basically figure this out. It's a very, very complex task, but it's arguably the most exciting one as well of the three, I would argue.
And very excitingly, Mark works very closely with probably the most eminent neuroscientist in the world at the moment, Carl Friston. They're close collaborators. And Carl is also an advisor to Conscium. So with them and with some of the other advisors we've got, we're assembling the dream team of neuroscientists and computer scientists to work on this. What can you tell us about other members of the advisory board?
One of the strangest things that's happening in this modern AI landscape is that AI is being researched and progressed forward. Most people like myself, computer scientists, engineers, which is amazing and leads to capability in terms of functional benefits. But there is a very silent community of very, very smart people from psychology, anthropology, from ethics, from neuroscience that have a lot to offer and they're not being listened to. That's one of the key contributions of our effort. We're taking a very different approach. So instead of just jumping in and trying to build something that's computationally effective or that achieves certain capabilities, we're starting from that community, from basically assembling that team that you mentioned yourself. We're trying to assemble a team of individuals with very, very diverse backgrounds. Some of them don't agree with each other always in this space, which I think is beautiful, to be honest. And we're trying to tackle consciousness along with trying to develop different types of AI. Instead of basically developing AI and then hoping that consciousness doesn't manifest or manifests in a benevolent way. I think we're taking a very, very different approach.
How will you know if you're making any progress in this? The reason I ask this question is that there are some prominent AI researchers who say that all this discussion about AI and consciousness, it's intellectually intriguing, but it never produces anything useful.
I think that's exactly the key contribution of this first stream, to define the framework, the principles, the tests that you need to detect and measure consciousness. There are different levels of consciousness as well, I would say. It wouldn't be a binary concept. It would have different levels. There is a ton of work in this space that we're going to leverage and improve on. I don't want to say too much, but there are some very, very exciting techniques that we can use, some very, very exciting developments that we plan to build on. So I think it's very, very doable. But I think we have to start with the principles and the framework. And once we have that, then you can basically design AI and develop AI based on these principles. And again, I fully expect people to disagree, to have their own opinions on how to define consciousness, and that's okay. The plan in this first phase of this first stream is to assemble all different opinions and basically agree collectively, as a species, I would argue, ideally collectively agree on what we consider to be conscious. And once we have that, then we can start actually measuring it in AI.
You've said that there might be various different levels of consciousness. Might it also be that what we call consciousness is actually multiple different lower level things which happen to be coincident in humans and mammals, say, but might not all be coincident in AI systems?
I would even go a step further. My personal opinion, of course, no one knows, I could be very wrong about this, is that the way AI manifests consciousness, if and when it does, it will be quite different from the way we do it. So we'll do our very, very best to define it from a human lens to start the effort. But I fully expect to be surprised along the way. And again, we're going into this with that expectation to possibly be surprised, take things slowly, and discover how things actually manifest in the AI domain step by step. So yes, I think consciousness is a very variable concept, even within biological beings. Once you move to AI, it's a different game, I think, altogether. That's why, for me, the scariest thing is accidental consciousness in AI. If it is to happen, if it is to manifest at some point in time, I want it to be because we were ready for it. And we even planned for it. That's exactly the motivation. I know it will be different, but we have to start somewhere. And I think this is the perfect time to do it at the precipice of AGI. We might even be a little bit too late. Not to sound gloomy or anything like that, but we're moving fast, as you guys have seen. And by we, I mean collectively. There's different companies, different organizations moving on this. This aspect has been a bit left behind. And I think it's time to start the process now.
Yeah, I think that's right. I think Conscium's timing is excellent in a number of ways. One, as you say, it's high time we did this. Another is that consciousness used to be a dirty word in scientific circles, in neuroscience circles. A lot of neuroscientists who are well established were told in their early careers, do not talk about consciousness because it will destroy your career. And that's changed. It's changed partly because it's becoming clear that with AI tools, we've got better ways of understanding it. And it's becoming clear that it's imperative that we do understand it. There is no consensus about what consciousness is, how it arises. There are quite a few well-established competing theories, like the global workspace theory, the integrated information theory, and a series of higher order theories. One interesting approach in a recent paper was to take each of those theories in turn and say, if that theory is correct, what markers would it throw up, which would enable us to judge, oh, okay, so this machine is now intelligent. And somewhat to my relief, at least, it went through all those markers and determined that none of the large language models or other AIs that we have today are yet conscious. So we're not too late, hopefully. Although consciousness feels like a bit of a black box, feels like something that is really hard to get to grips with, really hard to even talk about, there are ways to analyze it. There are ways to address it.
And we cannot afford to keep treating it as a black box or a dirty word.
Just to build on what Ted said, I was very fortunate to have breakfast with Mark Solms a few days ago, and not only is he a great mind, he's a great human being, so we're looking forward to collaborating with him in his group. A few days earlier, I was also very fortunate to end up on a yacht in Cannes speaking to Elon Musk about this very concept, which, by the way, is top of his mind, and he thinks that in the next year we're going to see machines that are smarter than us. I think it's going to take a little bit longer, but this is the right time. I should say that there are academic studies in looking at animal consciousness and trying to identify the behavioral markers in animals. Nicola Clayton, for example, is one of our advisors. She's worked very closely historically with Jonathan Birch, which is also somebody that's been advocating rights for animals because of his research in consciousness. So we've managed to amass, I think, an incredible team, and we'll continue to attract leading thinkers. If you look at our work streams, identifying what we agree on what consciousness is one part. Identifying the behavioral markers is another. Building AIs that we can then steer towards embedding those behaviors is the second work stream. And we're betting on neuromorphic computing, spiking neural networks, new emerging technologies. I say emerging, they've been around for the past few decades, but they're now becoming quite popular in industry that are much more aligned with how our brains work. Large language models are not how our brains work. They are statistical representations of the world. We are starting to see an emergence of technologies that are modeled on how our brains operate. And we think that that's probably the technological architecture abstraction layer to explore some of these ideas of self and sentience. And then the verification work stream is how do we then simulate, how do we formally prove that those AIs have those behavioral markers, and also how they might somehow align with behaviors we might want AI to have. So can we evolve agents or AIs to have behaviors like altruism and cooperation and sacrifice? If we are ultimately going to build machines that are as smart or smarter than us, could we somehow align their values with human values, which historically I thought was going to be impossible, but now I think we might be able to do it.
Will that verification involve not just looking at behavior, but somehow looking inside their minds, seeing what's going on in these vast neural networks?
Yeah. You've probably seen over the past several years, lots of research in looking at using fMRI, looking at human brains and their activities, and then trying to recreate how people are thinking and what they're thinking about. So we think there's probably going to be an intersection between what's currently being researched in terms of looking inside human brains, but also AI brains. Broadly, verification or testing has two types, two approaches. The first is simulation. Can you run those AIs in scenarios and see if they behave in the way that you want them to behave? But then you have to prove that they won't behave in a way that you don't want them. That requires formal verification. It requires a whole, again, different field in computer science that's historically been used to look at verify software and hardware. So can we make sure that software and chips behave how they want them to behave? But we now need a whole verification methodology to apply to AIs to make sure that they behave in a robust way.
While we're on the subject of this third work stream of verification, Daniel, do you want to talk a little bit about moral me?
The first work stream, the consciousness work stream, is defining consciousness and they're trying to identify behavioral markers. But it is also trying to understand value systems and what behaviors we might want to identify to align with some value system. Now, I'm not saying we're going to agree as a species on some value system. I think we need to work towards it. But how do we then, first of all, create a value system? Moral Me is an application, an app that we're going to be launching hopefully in the next few months that will allow people from around the world to create their own moral dilemma. So you'd be able to write a moral dilemma like the trolley problem or the prisoner's dilemma or any moral dilemma that you might imagine. And what we then want to do is we want to crowdsource people's answers to those moral dilemmas. Now, of course, you're going to get a diverse set of perspectives based on your religious beliefs, your age, your nationality, etc., etc. But understanding how humans approach these moral dilemmas gives us a starting point to be able to use and benchmark against AIs. The idea is that we'll have thousands of test cases, i.e. moral dilemmas. We'll understand how human beings answer those moral dilemmas, and then we'll be able to run AIs across those moral dilemmas to see how they diverge. Or we'll say this AI over here has the moralities of this group of people, or it diverges from the average human in these other areas. So it's a way of identifying test cases to test the morals of AIs.
The responses that people give to moral dilemmas are very interesting. They're often kind of counterintuitive, but also surprisingly consistent, given that there are so many different moral codes that people live by, so many different religions which throw out different moral codes. You might think that people would always disagree about everything. But to take the trolley problem, for instance, famously, the idea is there's an out-of-control train and it's going to kill 5 people unless something happens to move it onto a different track. And if it moves onto that different track, it'll only kill 1 person. And all around the world, all sorts of different national ethnic backgrounds, most people would throw a switch in order to divert the train so it kills 1 instead of 5. Almost everybody would not throw a large human off a bridge in front of the train in order to stop it and save the 5 people, even though the result is exactly the same. So it's counterintuitive, but consistent. And it may well be that moral me will show there's lots of other moral cases in which we are like that. That would help a lot. Let's dig into a little bit to the second work stream, which is creating advanced agents. And as you say, Daniel, neuromorphic is a route we have high hopes for. The fundamental idea in neuromorphic computing is sparsity. That's the most important difference. So most computers today, pretty much all computers, operate on what's called a von Neumann architecture, named after John von Neumann, a genius polymath, Hungarian, one of the fathers of modern computing. One of the attributes of that architecture is that every moment, every single artificial neuron in an artificial neural network is firing, is, to use the human expression, spiking. In a human brain, individual neurons spike very rarely. And as a result, the human brain operates on the energy of a light bulb, whereas it takes the energy of New York City to train GPT-4 and not much less to run it. The difference in energy consumption and indeed in brittleness is enormous. Neuromorphic computing, as you say, has been around for quite a while in theory, but nobody's managed to scale it so far. And we're working with some people that we hope will make it possible to scale it, and we'll have a different paradigm for advanced AI computing, which could be tremendously powerful.
I think we're definitely missing something when it comes to how the brain works. We're missing a lot. If someone asked you, let's say 3-4 years ago, how much do we know about the brain, the human brain, or even today, I think there's a ton that we don't know. But somehow we have created AI that is almost as smart as us and will be smarter than we are soon, which is, again, quite a concern. Because, again, we don't understand our brain, let alone a smarter brain that's going to be around artificially over the next months or the next few years. So that sparsity, in my mind, has 2 major benefits. The first one is energy. The current approach, as amazing as it is, isn't very sustainable. It will only get worse. So we will have to somehow innovate in the energy space to keep this pace up. But even that, I think, is quite risky. The other benefit, though, is that sparsity allows you to be a lot more transparent and to make this a lot more interpretable, I should say. So think of a massive, massive, massive graph, a massive network that has billions of parameters, billions of little numbers attached to it, or even trillions these days. And somehow in all these trillions, you need to figure out how it's thinking, how it makes decisions. And these numbers are constantly, all these neurons are constantly firing as it's being used. It's a very busy landscape, very hard to navigate, very hard to go into that and figure out how it's thinking, if you will. In a sparse setting, though, you have a much more parsimonious, selective landscape. So when things happen, when the AI does something, then specific parts of its brain light up. Far, far less parts of the brain light up. So we can learn a lot from neuroscience. We are in Conscium learning a lot by working with top neuroscientists. I think transparency and interpretability are going to be super, super important, both for developing AI and for understanding it. For verification especially, it's much easier to verify a sparse network where a few things are lighting up occasionally versus trying to understand a super, super dense network with trillions of lights going on at the same time. So it's about that. It's about energy, obviously sustainability, but at the same time, it's about keeping things simpler and more interpretable, more transparent.
Yeah, I think that's a really important point. Large language models create matrices of vast numbers of quite large numbers, which are related to each other with vectors, which are also numbers in multiple dimensions. So if you ask a large language model to explain how it got from premise A to conclusion B, it could tell you, but you wouldn't understand the answer because it would consist of large numbers in many, many dimensions. And we can only think in terms of 3 dimensions, and we're not very good at dealing with numbers with more than 7 digits in them. So if we can make sparse networks very smart, then we've got a much better shot at verification.
Exactly. And think about, so the human brain has access to all these amazing capabilities 24/7, basically across space and time, all the time, with only 20 watts of electricity. So there is a better way. There is a more transparent and more sustainable way, and we'll do our very best to get close to it.
The other approach to dealing with all these dimensions is that a clever AI will do what's called a dimensionality reduction. It'll be able to say, well, I know there's thousands of dimensions here, but it turns out that these 3 or 4 are the ones that are critical to a decision. That's an alternative approach. How do you assess that?
That's a well-established approach. It's a bit less applicable in neural networks because we don't exactly have a nice table with 1,000 or 2,000 dimensions. It's a network. It's a graph. Think of a very, very complex network with numbers attached to every edge. In that setting, what you're describing would be akin to essentially reducing some of the edges, cutting some of the edges off, basically, or turning off some of the light bulbs on the network. But that's hard. It's very hard to figure out which ones to prune. So there is work in that space, but when you have numbers in the trillions, and it will only get bigger, it won't get smaller at this space, that technique, I think, will only get you so far. It won't get you close to interpretability and transparency. It might make you a bit less energy hungry, and there are efforts to quantize models. To put it simply, all these numbers are floating point numbers like 0.62, 0.74, to discretize them and make them integers, for example, so that they take less space. So all these things do happen, and they do help a little bit, but it's a drop in the ocean compared to the pace that we're at now. So we need something a bit more radical. Relevant to your point is the way these models are being trained today. Yes, you need energy. And yes, you need tons of parameters in a very, very large network. But you also need tons of data. You need tons of historical data that encode our knowledge as humans, our experience as humans. So think documents, audio files, videos, images. You need to somehow find them in vast amounts and fit them into the model. In that sense, the model basically learns from others' experience. It's like me learning how people argue by watching them argue, essentially. And then someone describes to me, look, Calum is angry at Daniel because he's waving his hands and he's getting all red and he's upset. So I'm not actually experiencing it. I'm not learning it organically or incrementally. I'm just studying a billion videos of arguments. And then I get very, very good at mimicking how people act when they're angry or they're arguing, but I don't actually know what it is. And the person who created me definitely doesn't know how I perceive it. It's a very strange way of learning, and it's not how we do it in the human domain. So one of the key, I think, elements we're going to try to inject into our approach is that incremental experiential learning for AI. So instead of dumping in a massive amount of data on a massive, massive network full of electricity and then the rest of it, we're going to try to evolve the way AI operates and the way it learns through slowly taking it in different, more increasingly complex and interesting scenarios. So it will, if you will, in a way, experience different settings. It will try different combinations. It will try different ways to overcome a challenge, to solve an argument, to collaborate with another entity. And then through that process, through trial and error, essentially through failing, experiencing failure, it will basically learn how to improve. So it's a very different approach, possibly a slower approach compared to the way it's done now. But I think it's more sustainable, and I think it's definitely safer because you're in control of the pace.
We should talk briefly about the rest of the founding team. There are two other splendid members, Ed Chave, who's the business management COO, and there's Panos. I like to think of Panos as being a hardware guru. I'm not quite sure he completely agrees with that, but that's the way I see him. And then there's WPP, which is, many people will know, the world's largest media and advertising company. They may seem like a rather odd partner. So Daniel, do you want to explain WPP's role in Conscium?
I think it's a fantastic partner. WPP obviously acquired Satalia. Satalia has a pedigree of building scalable, safe AI solutions. We understand how hard it is. We understand that we're facing into an industry that's going to be transformed by AI, not just large language models. And so WPP obviously wanted to make sure that they're on the forefront, the bleeding edge. There is something very interesting here about perception. Media marketing communications, they're in the business of understanding how do people perceive things, genuinely perceive things. And then how do you influence, hopefully in a positive way, that perception? My belief is that over the next several years, the intersection between neuroscience and media marketing communication is going to get a lot tighter. But if we're building brains that are much more aligned with how biological brains work, if we learn about how those brains operate and think, that might also help us understand how we perceive things, which I think is incredibly beneficial to WPP. WPP, of course, work with the leading technology companies around the world. They have a plethora of data in understanding audiences, how to create content that activates audiences. So that's really where the relationship started. But I think that Mark Reed and the rest of the WPP leadership understand that there's some emerging technologies and have encouraged us to make sure that we're at the bleeding edge.
The question I want to ask is about grounds for optimism. I'm hearing lots of grounds for optimism about new technical solutions, also optimism that you brought together a bunch of really bright thinkers in the field of consciousness, and also optimism about support from WPP. But does this make you more optimistic that the AI that will be produced will be safe and beneficial in the world, rather than, as many people fear, impossible to predict, impossible to understand, and therefore impossible to control?
The whole point of Conscium is AI safety. So if we decide that it does not make sense or it's not sensible to build conscious machines, then we need to make sure that we don't and that other people don't. So this is grounded in AI safety, and WPP are absolutely on board and encouraging that approach. I was actually going to turn the question around, David. You've been thinking about this stuff for many, many decades, and I'd obviously love to hear Calum and Ted's approach. By the way, one of WPP's values is optimism, and I personally am optimistic. I wouldn't be on this podcast right now. I'd be on a desert island if I wasn't optimistic about the future. But you've been thinking about this stuff, David, for a long, long time. How do you feel about the future? How do you feel about consciousness? And how do you feel about Conscium?
I think it's a great initiative. The reason I have some optimism for the future is because we humans are individually clever. We can collectively be clever when we get our act together. And with the help of narrow AIs that we can carefully configure so that we do understand them, we can be even smarter. And out of that huge 8 billion brains augmented by AI, there ought to be possible ways forward to create superintelligences that will not destroy us or will not have an inclination to behave badly. We may discover through that process that we need to put extra features into the AI, or that we have to exclude features from the AI. I'm not sold yet on whether we should be putting in consciousness. I look forward to breaking down consciousness, and it may be that some things that we speak of as consciousness should be in the AI, and other things that we speak about as part of consciousness shouldn't be. But I think it's absolutely time to have this conversation. And as Ted said, it's time to accelerate having this conversation and keep a close eye on things. That we shouldn't just build momentum and set ourselves on a course that we can't subsequently adjust. We should have smart people, which you've assembled, kicking holes in the argument, challenging it. And so long as that's paramount, I have good confidence that true understanding will emerge.
Indeed. Maybe, Ted, do you want to talk about the paper that we've commissioned from Oxford?
Sure. As I mentioned before, I don't expect everyone who hears about Conscium to be immediately excited about the idea of consciousness and AI and consciousness. I know it's a very, very scary thought. I also know that this is the time to start researching it before it gets out of our hands. With that in mind, we're working with a team from the University of Oxford to basically write a paper exactly on this, to write a paper on the framework, if you will, the foundations of research, study, and work in the area of AI consciousness. What are the risks? How it should be done, how it shouldn't be done. This has been a very interesting collaboration for us because at the very beginning, they were very, very, very hesitant, very guarded. So their first response was, no, they shouldn't be done. And to me, personally, it was a very illuminating experience because it made me realize how many concerns we're going to face along the way. So as we work with brilliant people in this space and we address their concerns, we absorb their feedback, then we're getting better at doing this as safely as possible. And this is one of many steps. If you look at our advisory board, very diverse gallery of opinions, disagreements on different things. So we don't have the answer yet. We're not close to solving consciousness yet. We just want to know how it can be done, if it can be done, and then we can decide if it should be done collectively. But it will be in a very, very transparent way. And if at any point in time we decide, and by the way I mean collectively, as a team, even as a species, I would argue, that this should not be done, then it won't be done. But at the very least, I think we need to know if it could be done and how we can measure it, how we can detect it, how we can avoid exploiting it. This is, I think, a mission worth pursuing. And the University of Oxford collaboration is going to lead a publication, I think, hopefully very, very soon, that will show you our way of thinking and responding to many of these criticisms. Because I think they're very fair concerns, very, very fair concerns.
I think that's very well put. We've already talked about one of the imperative reasons to be able to detect consciousness in AIs, and that is to avoid mind crime. There's another possible reason why, if we had a choice between the first superintelligence being conscious and being not conscious, we might choose to have it be a conscious one. And the reason for that is that we think quite a lot of our value derives from the fact that we are conscious. If humans all stopped being conscious, I think many of us would agree, we'd have less value. A machine which has no consciousness, has never experienced consciousness, cannot really understand that value. Whereas a machine which has consciousness, or has at least experienced it, should be able to have some empathy for other creatures with consciousness. So I think we might be in a better position. To go back to your question, Daniel, I'm not one of the many people who think that if we get superintelligence and we don't know how to control it, that necessarily means we're doomed. I think a superintelligence which is out of our control may well be extremely good for humans. I think there's possibly a minority view, but I do take that view. And I think it's more likely to be beneficial for us if it's conscious. But Ted, as you say, this is all very much to be agreed, discussed, determined, and we're not in the business of taking unilateral steps towards radically new positions.
Yeah. If we are going to be building ever more intelligent machines, ensuring that they have some sort of alignment with values gives us a better chance of the bad scenario not happening.
Yeah.
So what's happening next? You alluded to things that might happen in the future. Do you have timescales you can talk about, or is it all still stealth?
Well, Daniel's going to carry on swanning around yachts in Cannes and elsewhere and talking to extremely rich people and get us some funding to do all these incredibly ambitious things that we're going to do.
The feedback so far from the sort of ultra high net worth community is that this is something that they want to be involved with. It's a really important event in human history that we need to face. So we are looking at raising capital from different investors, and we have a number of different activities happening across those 3 work streams. And really, it just depends on how ambitious we want to be, the amount of money that we raise. Hopefully in the next several months, we'll be able to accelerate Conscium. So if anybody's interested in engaging, being involved, please do reach out.
And the way you can find more information about it is we're at www.conscium.com. And we have a series of meetups, which are called Conscious AI meetups. We've done, I think, 3 so far, which have been absolutely fascinating and a real workout for the brain. If you want to try and get to grips with consciousness, those meetups are a great place to start.
It's been a great conversation. Anything you want to add finally, Daniel or Ted?
Just to say that this is the first time in human history that we're going to share the planet with someone who is smarter than we are. And it may sound scary, it may sound impressive or interesting, but it is going to happen. So that's the motivation of this effort. First and foremost, we need to know more about that new being, about that new entity. Just think of us in this way. Don't think of us as trying to take over the world or make the new Terminator series or anything like that. We are mostly motivated by the same concerns as you are. Fully, I would say, motivated by the same concerns as you are. So that's what I would basically leave you with.
Yeah, we're definitely more Star Trek than Star Wars.
Indeed, I think this word has been mentioned a lot, which is we want to amass the most diverse group of experts and use our resources to make sure that we're pointing those brains at the right questions over the coming 10 years.
So if anybody's listening to this and feels that what they've heard expressed isn't diverse enough yet, and if you have a history or a perspective that needs to be shared, at the very least, attend the meetups and reach out to Conscium to get involved in the conversation too. Thanks, everyone.
Thanks, guys.
Thank you.
Thank you.